Hello everyone, I'm Arthur from Amitime Heatpump. Today let's focus strictly on the underlying physics of aerosol thermal technology. Many wonders how heat can be extracted when it's freezing outside. From a thermodynamics perspective, as long as the ambient temperature is above absolute zero, the air contains low-grade thermal energy derived from solar radiation. And aerosol heat pumps utilize refrigerant as a conductive medium to absorb, compress, and extract this ambient heat. In practical applications, the main technical bottleneck for commercial contraction is that below -12 degrees Celsius, a standard single-stage compression cycle suffers from insufficient suction and excessive discharge temperatures, causing a sharp drop in heating capacity. To overcome this physical limit, Amitime integrates EVI 2.0 enhanced vapor injection technology by introducing a secondary subcooling heat exchanger. It intermediates vapor injection into the cycle. This lowers discharge temperatures and significantly boosts the refrigerant's heat absorption efficiency within the evaporator, maintaining stable thermal output in extreme cold. Beyond low temperature heat absorption, frosting control is critical to operational efficiency. Traditional heat pumps mostly rely on a single temperature sensor, which often causes frequent forced frosting and wastes energy. Amitime utilizes Omni-Sense smart defrost technology, which monitors running voltage, current, core temperature, and air pressure in real time. By establishing a multi-dimensional mathematical model, it precisely assesses frost thickness to ensure the system only defrosts when necessary. Coupled with the step-based adjustment of 4 DC inverter compressors and variable speed models, the system achieves a heating IPRV of 3.72, significantly optimizing energy conversion compared to traditional electrical resistance heating. Finally, regarding indoor comfort, the primary difference between a heat pump and the standard direct expansion AC system lies in the thermal transport medium. The heat pump primarily uses water as the primary medium for heating and cooling. Since water has a much higher specific heat capacity than air or refrigerant, transferring thermal energy through a plate heat exchanger ensures a general, more stable heat release. Indoor humidity levels remains balanced, eliminating the dry discomfort associated with standard DX system and aligning better with physiological thermal comfort standards. For Arthur from Amitime Heatpump, your best global energy transition partner in China.